Solve each quadratic inequality. Our first inequality, we have 3x squared plus 9x less than 0. Ultimately, we want to find all values of x such that when they are plugged into this statement, you get a true value. First step in these quadratic inequalities is to find key numbers. These are the zeros of your original problem. 3x squared plus 9x is equal to 0. We can solve by factoring 3x times x plus 3. 3x equals 0 when x equals 0. X plus 3 is equal to 0 when x equals negative 3. Step 2, plot your key numbers on a number line, negative 3 and 0, and then we're going to test around those. There's 3 intervals. The interval to the left, I picked negative 4 as a test number. Substituting negative 4 into the original problem, I got a false statement. 16 times 3 is 48, minus 36 is not less than 0. So I just made a note that that was false. Next, pick a test number between your key numbers. I just chose negative 1. Substitute in negative 1 into your problem. 3 times negative 1 squared plus 9 times negative 1, that is negative, that's true. And then the third interval is to the right of your second key number. I randomly picked a 2, plugged that into the original problem, got a false statement. 12 plus 18 is 30, that's not less than 0. The only interval that gave a true statement was the one in the middle. Now, because our inequality is strictly less than, it's not less than or equal to, you have to use parentheses at your key numbers. So in part 3 over here to your bottom right, the only interval of truth was from negative 3 to 0. In our next example, x squared is less than or equal to 36. In these, I like to have a 0 on one side just because they're quadratic. So subtract 36 on each side. That gives you x squared minus 36 is less than or equal to 0. It's also helpful when you get ready to find your key numbers. So x squared minus 36 is exactly 0 when x is either negative 6 or positive 6. That can be factored as a difference of 2 squares. On your number line, sketch a number line, mark off your key numbers of negative 6 and positive 6, and then we're going to pick test numbers in all 3 intervals, and we'll test them out in the problem. Negative 7 is in this first interval. That'll work for a test number. Substitute in. Negative 7 squared is 49. That's not less than 36, so we get a false statement. 0 is a good option for a test number in this middle interval. 0 squared is less than 36, so that's true. And then we pick a number on the right of our second key number. This is in the third interval of numbers. 7 squared is not less than 36, so that's false. The only interval of numbers that gave a true statement is the interval between negative 6 and positive 6, including your key numbers, because we can be equal to 0, and that's what you're actually finding in step 1. X squared minus 8x plus 2 less than 11. I don't have a 0 showing, so I'm going to subtract 11 from both sides. X squared minus 8x, 2 minus 11 is negative 9, and that's less than 0. This is an equivalent statement. Find our key numbers. X squared minus 8x minus 9 is equal to 0 when x is equal to negative 1 or positive 9. This trinomial will factor with a positive 1 and a negative 9. The sum of these two numbers is negative 8. The product of these two numbers is negative 9. Solving each factor equal to 0 gives us key numbers of negative 1 and positive 9. I've highlighted the statement I'm going to plug the test numbers into. This first interval, I picked -2 as a representative, substituting in -2 for x. Calculate, we get a false statement. I picked 0 as a representative for the middle interval between the key numbers. 0 subbed into this highlighted statement gives a true statement. That's good. And then I picked 10 as a representative from the third interval, substituted it into the highlighted statement, and got a false reading. 100 minus 80 minus 9 is not less than 0. The only interval of truth was between the key numbers. Our inequality is not underlined, so parentheses all the way. Any number between -1 and 9, not including the end numbers, will satisfy this problem. X squared plus 6x greater than 7. I'm going to subtract 7 from both sides, get everything on one side. Our statement is greater than 0. X squared plus 6x minus 7, let's get those key numbers. The key numbers are when your problem is exactly 0. This is how you find the cutoff numbers. This trinomial will factor with a +7 and a -1. The sum of those two numbers is 6. The product of those two numbers is -7. Set each factor equal to 0 and solve. You will get -7 and +1 for your key numbers. Testing the intervals around the key numbers, -8 substituted into the highlighted statement. 64 minus 48 minus 7 is positive, so that's true. Pick a number between the key numbers. 0 is always convenient as long as it's not a key number. I always pick 0 for a test number. Substituting 0 into the highlighted statement above, you get a false statement. 0 plus 0 minus 7 is not greater than 0. And then the third interval, I just picked a 2. Any number larger than 1 will work. 2 subbed into the highlighted statement. 4 plus 12 minus 7 is positive. That's greater than 0. That's true. This time we have true statements on the first and third intervals. The first interval is any number less than -7. Well, as you go left on a number line, you get really deep into the negatives. -infinity to -7 is this first interval. We don't have any good numbers in between the key numbers, so we don't use this middle interval. But once we get to 1, anything larger than 1 will satisfy the problem again. So 1 to +infinity. As you go right on a number line, your numbers get larger and larger. The solution is the union of those two separate intervals, and that's what this union symbol is for. Our overall solution is the union of the first and third interval of numbers. Our last example, we have x squared greater than 2x plus 3. So I'm going to quickly solve by, or at least get a 0 to show up by subtracting 2x and subtracting 3 on both sides. This statement is equivalent to x squared minus 2x minus 3 greater than 0. X squared minus 2x minus 3 set equal to 0 will give us key numbers of -1 and +3. Plotting -1 and +3 on a number line, and then picking test numbers from the 3 intervals between and around. There's 3 intervals total. Testing into the highlighted statement, -2 substituted in. That's 4 plus 4 is 8, minus 3 is 5. That's greater than 0, so true. 0 is a good test number for the middle interval. Substitute into the highlighted statement, 0 minus 3. That's not greater than 0. That's false. And then finally, I picked 4 to test the third interval. 4 squared minus 2 times 4, that's 16 minus 8 minus 3. That is greater than 0, so true. The first and third intervals contain all the good values of x that will satisfy the problem. The first interval, any number less than -1. The third interval, any number greater than 3. The union tells us that any number from those two intervals will count as a solution.